Hello friends and my dear students, I welcome you all to my channel. This is the new chapter Force and Pressure that I have started. This is part 1 video where I will discuss about the units of force. Please note that in this playlist, that is ICSE Physics for class 8, I only discuss about the concepts and formula that are required for solving numerical problems. I won't be discussing any theoretical concept. So in this part 1 video of units of force, I will discuss about the SI and CGS units of force, gravitational unit of force, and how to convert from one unit of force to other. So units of any quantity is very important to understand. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case please do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 1 video. Sorry. Let's start part 1 video of the chapter of force and pressure, where I will discuss about units of pressure. Units of force. Okay, so I have written down few notes. I am not really that well prepared. Let's see how it goes. So primarily I will discuss about the three units of force, that is SI, CGS and gravitational, and we'll try to see how we can convert from one unit of force to the other unit of force. Okay. The SI unit of force is Newton, which is denoted by capital N. Now what is 1 Newton? 1 Newton is the force when applied on a moving body of mass 1 kilogram in the direction of motion, increases the speed by 1 meter per second in 1 second. That is, after every 1 second, the speed of the body, which is already in motion, is increasing by 1 meter per second. As the unit of speed is meter per second, so the speed is increasing by 1 meter per second every second. So this is the fundamental definition of 1 Newton. That is, 1 Newton is a force if you apply on a moving body of mass 1 kilogram in the direction of the motion. It is important that you apply the force in the direction of motion. Now you must be knowing that force is a vector quantity. That is, to define a force, you have to provide the magnitude and the direction, and a force is usually visually denoted with the arrow notation. So this is a force, and force is generally two types: a pull or push. For example, if you are applying this is a body, let's say this is a pull force. Similarly, if this is the body, this is a push force. Anyway, so this is 1 Newton. 1 Newton is the force when applied in a moving body on a mass of 1 kilogram in the direction of the motion, increases its speed by 1 meter per second every second. Okay. Now what is the CGS equivalent? CGS unit of force is dyne. Now the concept is very similar. 1 dyne is equal to the force when applied on a moving body of mass 1 gram in the direction of the motion, increases the speed by 1 centimeter per second. The concept is same. In the SI unit, the body was having mass of 1 kilogram. In the CGS unit, the body is having mass of 1 gram, and in the SI unit, the speed was increasing by 1 meter per second, and in CGS, the speed was increasing by 1 centimeter per second. So Newton, that is capital N, is a unit of force in SI unit, and dyne is the unit of force in CGS. Okay. Now let's see gravitational unit of force. We have two. One is kgf, which is known as kilogram force, and the other one is gf, which is known as gram force. Now what is 1 kgf? Now this gravitational unit of force is related to is defined by the force of gravity that acts on a body. We know that the earth attracts everybody towards the center of the earth, and this attraction is causing a body of some mass to have a weight. As we know that weight is the force, is the gravitational force by which a body is attracted towards the center of the earth. Okay, so what is 1 kgf? 1 kgf is the gravitational force acting on a body of mass 1 kilogram. That is, wherever the body is. Now you must also be knowing that the force of gravity varies from place to place. From the surface of the earth, if you go at high altitudes, the gravitational force decreases, as well as from the surface of the earth, if you go deep inside towards the center of the earth, the gravitational force decreases. So obviously the gravitational force is maximum near the surface of earth. Okay, now 1 kilogram force means the gravitational force. Now this gravitational force does not mean the gravitational force near the surface of the earth. It could be anywhere. It could be even at the same, it could be at a high altitude, or it could be below the surface of the earth. Wherever it is, and wherever it is just saying that it basically it basically is depending on the mass of the body. 1 kgf means gravitational force wherever the body is, and whatever the gravitational force of attraction at that place is. So the gravitational force acting on a body of mass 1 kilogram. Now, quite obviously, this gravitational force will obviously vary from place to place. If at some, let's say at okay, I will discuss that later on. Now, so what is 1 gf? 1 gf is the gravitational force acting on a body of mass 1 gram, wherever, irrespective of the location of the body, wherever the body is, and in that location, whatever the gravitational force is, that gravitational force which is acting on that body of 1 gram is 1 gf, 1 gram force. So we know, so quite often we define the weight of a body with kgf or gf. So let's say there is a mass 1 kilogram. Let's say this is a body of 1 kilogram mass. Now let's say we are talking near the surface of the earth. Sorry, near the surface of the earth, we know that its weight W will act vertically downwards. What will be this W? This will be nothing but 1 kgf. This W weight is nothing but the gravitational force that is acting on this body of 1 kilogram, which is 1 kgf. Similarly, if we are having a body of 1 gram and the weight, so the weight of one body of mass 1 gram is nothing but 1 gf, and the weight of body of mass 1 kilogram is 1 kgf. Okay, so now let's see how do we convert a value of force given in SI to CGS, and from CGS to SI. Okay, so if we have to convert, so converting a unit of force from SI to CGS means we have to convert from Newton to time. Okay, now by the way, this 1 Newton, 1 Newton is also defined as 1 kilogram 1 kilogram meter per second square. Now, so 1 Newton is equal to 1 kilogram meter per second square. Why is it so? The question is, why is it so? Okay. Now, you must be knowing, I don't know whether you know this or not, that based on the definition that 1 Newton is a force when applied on a moving body of mass 1 kilogram in the direction of motion, increases the speed by 1 meter per second in 1 second. This is there is another formula that force is equal to mass into acceleration. Mass into acceleration. Now, when it is saying that the speed is increasing by 1 meter per second, basically it is creating a acceleration of 1 meter per second square. And this is acting on a body of mass 1 kilogram. We know that force is equal to mass into acceleration. So, if I consider the mass to be of the body to be 1 kilogram, and the acceleration, the force F acting on the body of mass 1 kilogram, when it produces an acceleration of 1 meter per second square, that is, it is increasing the speed by 1 meter per second every second. I have acceleration is 1 meter per second square. This becomes 1 into 1 is 1. So 1 into 1, and then if I place the unit, this is kilogram meter per second square. This is also written as, this is 1 kilogram meter per second square, means second to the power minus 2. So 1 Newton is also equal to 1 kilogram. 1 Newton is also equal to 1 kilogram meter per second square. Using this information, we will try to convert a value of force in Newton to dyne. Okay, again, what is 1 dyne? As you can understand, I hope you will understand, if I say 1 dyne is equal to 1 gram centimeter per second square. 1 dyne is equal to 1 gram centimeter per second square, and 1 Newton is equal to 1 kilogram meter per second square. Okay. So let's see. I have 1 Newton. I have to convert it into dyne. 1 dyne is, we know, 1 gram centimeter per second square. So 1 Newton is equal to 1 kilogram meter per second square. Okay. Now the unit of second is same in both SI and CGS. I just need to convert the kilogram to gram and meter to centimeter. Okay. So this will be equal to 1. How much is 1 kilogram? How many gram is 1 kilogram? This is 10 to the power 3 gram. 1 kilogram is 10 to the power 3 gram. And how many centimeter is 1 meter? We know it is 100 centimeter is 1 meter. So 100 centimeter, and we have second per second square. So this becomes 10 to the power 3 multiplied by 100 gram centimeter per second square. This is equal to 10 to the power 5 gram centimeter per second square, and this is nothing but 10 to the power 5 dyne. So 1 Newton is equal to 10 to the power 1 dyne. Remember that 1 Newton is equal to 1 kilogram meter per second square, 1 dyne is equal to 1 gram centimeter per second square, and 1 Newton is equal to 10 to the power 5 dyne. If you cannot remember 1 Newton is equal to 10 to the power 5, you must always be possible. You should be able to convert from 1 kilogram meter per second square to something gram centimeter per second square, and then you know that 1 gram centimeter per second square is 1 dyne. Okay, so I will finally write down all the important formula. So 1 Newton is equal to 10 to the power 5 dyne. Obviously, from very common sense, what will be how many Newton will be 1 dyne? This should be obviously 1 by 10 to the power 5 Newton. This is equal to 10 to the power minus 5 Newton. So 1 dyne is equal to 10 to the power 5, 10 to the power minus 5 Newton, and 1 Newton is equal to 10 to the power 5 dyne. Sorry, this was conversion between SI and CGS units of force. Let's see how do we convert the SI unit of force to gravitational force, that is Newton to kgf, and kgf to Newton, and Newton to gf, or gf to Newton. Okay, now okay, now what is 1 kgf? We know that 1 kgf is nothing but the weight of a body of mass 1 kilogram weight of a body of mass 1 kilogram. Now what is that weight? That weight is the gravitational force acting on the body of mass 1 kilogram. Okay, now okay, so 1 kgf is the gravitational force that is acting on a body of mass 1 kilogram. Okay, now okay, now what is that gravitational force? What is that gravitational force? We know that the weight or the gravitational force or the force of gravity, the force of gravity is equal to mg. This F is the force of gravity that is acting on a body of mass m. What is this g? G is some constant. G is constant. This is g is acceleration due to gravity. Acceleration due to gravity. We are talking in general near the surface of Earth. So this is acceleration due to gravity near Earth or near Earth's surface, and this is a constant. Its value is precisely 9.8 meter per second square. It is sometimes, for the sake of calculation, for the sake of easiness of calculation, it is also taken as 10 meter per second square. I am taking it as 10. Okay, so we know that 1 kgf is the force of gravity that is acting on a body of mass 1 kilogram. Okay. Also, we know that the force of gravity is mg. So, if in the mg formula, if I put the mass as 1 gram, 1 kilogram, 1 kilogram, and this g is a constant, let's say it is 10 meter per second square. In the formula, F is equal to mg. This is the formula for the gravitational force that is acting on a body of mass small m, and where g is the acceleration due to gravity near the surface earth, and its value is constant, which is approximately 9.8 meter per second square, but we also consider it to be 10 meter per second square. I am considering it as 10. So if I put the value of g as 10 meter per second square and the mass as 1 kilogram, this becomes equal to 10 kilogram meter per second square. Now, what is 1 kilogram meter per second square? We know. So this is 10 Newton. Why? Because we know that we just discussed little earlier that 1 kilogram meter per second square is equal to 1 Newton. So we have the force of gravity acting on a body of mass 1 kilogram is 10 Newton, which is also 1 kgf. So I can say 1 kgf is equal to 10 Newton. I will quickly check if I am correct or not. Yes, I am correct, because I am really not prepared. I am just scratching my head and trying to derive. So 1 kgf is equal to 1 Newton. Okay. Now, okay. Quite obviously, what will be how many kgf will be 1 Newton. So from here only we can say that 1 Newton is equal to 1 by 10 kgf. 1 by 10 kgf. 1 by 10 kgf. Okay. So we know 1 kgf is 10 Newton, and we know 1 Newton is equal to 1 by 10 kgf. Okay. Now let's see what will be how many. Let's see how do we convert between Newton and gf. Now, okay, 1 Newton. Okay. Similarly, to know how many Newton it will be of 1 gf, I mean 1 gf is how many Newton. Let's apply the same concept. We know that if there is a body of 1 gram, the weight is, we say, 1 gf. The gravitational force that is acting on a body of 1 gram is its weight, or it is 1 gf. Again, consider the formula for the gravitational force. F equals to mg. G is constant. We will take 10 meter per second square. Now in this mg, F equals to mg, if I put the mass as 1 gram, and since we know the value of g is 10 meter per second square, g is 10 meter per second square. Now, so this is 1 gram, fine. I will now convert the meter to centimeter. So 10 meter, so 1 meter is 10 to the power 1 by 100 centimeter, so 10 to the power minus 2 centimeter, and we have second per second square. So now this becomes 10 multiplied by 10 to the power minus 2 gram centimeter per second square. This is equal to this is equal to 10 into 10 to the power minus 2 is 1 by 10. 1 by 10 gram centimeter per second square, and we know 1 gram centimeter per second square is 1 dime. So this is 1 by 10. This is 1 by 10 dime. So we got, okay, so now we can say that 1 GF is equal to 1 by 10 time. We got time. Okay. Now I was trying to convert 1 GF to Newton and I landed up with dyne. Okay, no problem. So 1 GF is 1 by 10 dyne. Now I know how many dyne is, I know the conversion between from dyne to Newton. I forgot. So 1 dyne is 10 to the power minus 5 Newton. 10 to the power minus 5 Newton. Okay. So this is equal to 10 to the power minus 5 divided by 10, this much Newton, and this is equal to 10 to the power minus 6 Newton. So 1 GF is equal to 10 to the power minus 6 Newton, and 1 kgf was 10 Newton. I will quickly check whether I am doing it correctly or not. 1 kgf is 1 Newton, 10 Newton, that is fine, and 1 GF is, where is 1 GF? Okay, it is not there in the book. Anyway, I think I am doing it correctly. If you think I am wrong anywhere, please feel free to let me know in the comment section. So I am getting 1 GF is equal to 10 to the power minus 6 Newton. Okay. What else? So I think these are the important conversion. So let me quickly summarize the important thing that you must remember. The the triple star are very important. If you forget this, you are doing a crime. So 1 Newton is equal to 1 kilogram meter per second square. Okay. 1 dyne is equal to 1 gram centimeter per second square. Okay. 1 kgf is equal to 10 Newton. I think these are the 3 most important formula or results you must be always aware of. Using this, I think you can easily convert from Newton to dyne, or dyne to Newton, and Newton to kgf or kgf to Newton. What was and how much was 1 gf? Now from 1 kgf to 10 Newton, I think you should be able to derive how many Newton will be 1 gf. So as I just did, 1 gf, 1 gram force is equal to 10 to the power minus 6 Newton. These are the most important uh, formula of conversion of units of force. Okay. That is all for this video, where I discussed about the units of force, SI unit, CGS unit, and the gravitational unit of force. What actually 1 Newton means, and that 1 Newton is equal to 1 kilogram meter per second square. This is coming from the fact that force, gravitational force, is equal to mass into acceleration, ma. Sorry, mass. Yes, mass into acceleration. One dyne, CGS unit of force is dyne. One dyne is equal to 1 gram centimeter per second square, and the gravitational unit of force, kgf, means 1 kgf means gravitational force acting on a body of mass 1 kilogram. Gf means the gravitational force acting on a body of mass 1 gram, and then 1 kgf is equal to 10 Newton, and 1 kgf is equal to 1 Newton, and I think these and 1 gf is equal to 10 to the power minus 6 Newton. Now 1 gf is equal to 10 to the power minus 6. You might forget this, but you can always derive this from 1 kgf is equal to 10 Newton. These are very, very important concept or formula results. Okay, that is all for this video. I will end the video here. Thanks for watching, and until the next video, take care and bye. And if you have any questions or to ask for any kind of clarification on what regarding this unit of force and the interconversion, then please feel free to let me know in the comment section. I will do my best to help you out. Thanks for watching, and until the next video, take care and bye.